Make the ground shake.
They have direction and magnitude. Vectors that tell us position at a certain time. Velocity, derivative of x and t, y and t. Acceleration important to take the second derivative. Watch us get A's and A's each time. Just know that parametric got one more t, and then you add vectors to write equations. And when apply calculus, we find the y dx. We listen to Mr. U. You got that distance, steep slope, direction. I got the equation.
So let's review number 3, part B and C on the test. The first part of the question asks for the total distance traveled by the particle from t equals 0 to t equals 4. Does anyone know the formula?
So the integral of square root of the derivative x squared plus derivative y squared dt.
That's right. The formula is written right here. Now it's time to plug in all the information given. From our prior knowledge, we know how to find the derivatives of xt and yt. The derivatives of xt is 2t and the derivative of yt is 6/5 t squared. Also, the upper and lower bounds is 0 and 4. Now, it is time to plug it in and find the solution. First, we're going to simplify the integral and then find the antiderivative. The antiderivative comes out to be 2 over 135 times 25 plus 19 squared to the 3 over 2 power. Now, part C asks for dy over dx as a function of x. The first thing you have to do is isolate t. In this case, t equals square root of x plus 2. The formula used in this part is that the dy over dx equals to dy over dt over dx over dt. So 6/5 t squared over 2t equals 3/5 t. All we have to do now is substitute for t in terms of x. So the answer comes out to be 3/5 square root of x plus 2.
What do you mean, how did I get that grade?
Are you serious right now? Like, I found this music video on YouTube. It's a parody of Style, and I really like the song Style by Taylor Swift. It's like my favorite song, so that's how I got the grade. Alright, so here goes. The question states that a moving particle has position x of t and y of t at time t. The position of the particle at time t equals 1 is 2, 6, and the velocity vector at any time when t is greater than 0 is given by 1 minus 1 over t squared and 2 plus 1 over t squared. Part A asks us to find the acceleration vector at time t equals 3. The first derivative of x of t is 1 minus 1 over t squared, and the first derivative of y of t is 2 plus 1 over t squared. I remember from the song that we had to find the second derivative to find the acceleration vector. The second derivative of x of t is 2t to the negative third power, and the second derivative of y of t is negative 2t to the negative third power. Now we just have to substitute t for 3, and the answer comes out to be 2 over 27 and negative 2 over 27. Part B asks us to find the position of the particle at t equals 3. To find x of 3, we need to find the integral from 1 to 3 of the velocity vector plus 2. The bounds are between 1 and 3 because the problem gives us the position of the particle at time equals 1, and we are looking for the particle at time equals 3. We add 2 because that is the initial position of the vector for x of t at t equals 1. Then we simplify the integral for x of 3. Now you go through a similar process to find y of 3. We have to do 6 plus the integral from 1 to 3 of the velocity vector. After all the simplifying and the solving, the answer for x of 3 comes out to be 10 over 3, and the answer for y of 3 comes out to be 32 over 3. Therefore, the position vector at time t equals 3 is 10 over 3, 32 over 3. Hello friends, I have a confession to make. So I stole her phone because she was trying to help me out with a test, and then she tried to give me her phone, but that's how I got the music video, because she gave it to me. So
Thank you.
bye.